Hello, welcome back to Cracking the Cryptic. Well, today we're going to take a look at this puzzle that's coming from Harry. And he said that it would be great if we could talk through slowly how to solve it, which I hope we'll be able to do. The reason I think this might be suitable for that is that obviously if we stare at the grid, there seems to be a lot of given digits. So I mean, it's not always the case. Sometimes you can get lots of given digits and still very difficult puzzles, but normally a lot of given digits is an indication that the puzzle may not be as brutal as sometimes. Now, if you want to have a go at the puzzle, click on the link under the video. That'll take you to our software, and you can have a try. Now, let's have a look and see what we can do with this. So I'll start with ones, and as usual, I'll try and go around the grid. Just highlight in 3x3 blocks where if I can restrict a number to exactly 2 positions, then I will, and I'll make little pencil marks to remind me of that fact. I don't think I can do anything in this box though, so let's move on to 2s. 2's not really doing anything. I think there's only 2 2's in the grid. 3's. Yeah, okay, so 3's can go into one of those 2 positions, one of these 2 positions. Still no actual digits in the grid though. Let's try 4's. Yeah, 4's we can lock into one of those 2 squares and one of these 2 squares. One of these 2 squares. Okay. 5's. Okay, I'm beginning to revise my my opinion about this puzzle. It's quite unusual for an easy puzzle anyway, to go this long without being able to enter a digit. 6's. 6's. No. 7's can be locked into one of these 2 squares. Again, there's only 2 7's in the grid. There's only 1 8. So maybe 9's are the place we're going to need to start. So 9's. One of those 2 squares because of these 9's here. So there are lots of 9's, so hopefully 9's will be fruitful. Okay. I think I must have missed something there. Okay, but what do we do in situations like this? Well, the next thing I would look at would be rows and columns with a lot of given digits to see if we can identify any restricted cells. So let's start with row 2 of the grid, where we need 3, 4, 7 and 8. And to see if we can find any squares that are particularly, you know, at least down to 2 digits, say. I can't actually see any of those squares. I'm now wondering whether I'm being trolled and this is actually a monstrous puzzle that someone's sent in under the guise of an easy puzzle. 1, 2, 3, 5 and 9 down here. Okay, well that square is restricted. That can only be a 2 or a 3. Ah, now that is interesting. That is very interesting. I'm just gonna check there's nothing easier. I have noticed something there, so do have a look at what I might have spotted off that 2 or 3, because it could be beautiful. In fact, I am just going to talk about it because it could be beautiful. So let's look at this. This square, just looking at the interaction of the row and the column and the box, can only be 2 or 3. Now if we look upwards, we've got a 2 and a 3 in this box at the top. Same as that number. Now this 2 and 3 obviously is preventing there from being a 2 or a 3 in either of these squares in column 6. So we come down the column here, we know there's a 2 or a 3 here, therefore there must be a 2 or a 3 in one of these 2 squares. But look, If we slide across here, there's also a 2 or a 3 there. Oh, this is very, very beautiful. So now, let's think about this. So there are two options for this. I'm going to do this slowly just because I think it's worthwhile. Let's imagine in the finished grid this was a 3. Now if this is a 3, I still need to put a 2 into column 6. And because of this 2 here, the only possibility would be that square. And that would lock a 2 into this position here. So I'm going to actually just write the 2 into that square. This square is the key one. Let's make it purple. Okay, so that's option 1, is if this is a 3. Now watch. If on the other hand this is a 2, now I need to put a 3 into one of these two squares. Remember, the 3 can't go up here because of the 3 that's in this box. So I need to put a 3 in one of these two squares. Now this time, this 3 matters. So I would have to put the 3 here, and this square, in this example, would now be a 3. So whichever choice I select for this square here, this square has a sort of parity with it. So this 2-3 effect going round the corner. Now it's incredibly difficult without noticing this 2-3 here to look at this square and realise it can only be a 2 or a 3. If we compare the contents of this column, just got a 1 and a 9 and a 6 and a 7 extra in the row. So to limit this to a 2 or a 3 is really quite massive. Now, this 5 all of a sudden, therefore, I'd never have been able to eliminate a 5 from this square, but now, where can a 5 go in this box? Well, it can only go in one of those 3 squares, because it can't go in the 2 or 3 square. And that means, coming over here, I get a digit. The 5 in this box must be in row 9, it must be there. And that took the position of a 4, so that means that that is... So we've got 2 digits now as a result of that logic. And now we've got a 4 and a 3 here, look. So this is a 3-4 pair. You can see the 4s marry up in rows 1 and rows 2 in these two boxes. So over on this side of the grid, or we need to put a 4 into row 3 somewhere. That's the other way of thinking about this. I sometimes look at this 4 pattern here as an X-wing, but a simpler way of putting it might be to say, where can I put a 4 in row 3 of the grid? Obviously in neither of these squares, because of the 4s in one of those two positions, and in neither of these squares, because we know there's a 4 in one of those two positions. So I know the 4 in this box must be in one of these 3 highlighted cells, and there's a 4 here, look. So actually, there is a 4-6 pair as well, over in this top box. 4, 6. So, what would the next step be? 4, 5. So these 3 squares are some combination of 6, 7, and 8. This square is a 6 or a 7. Here. Let's have a look into these squares now. So we need 2, 3, 5, and 8. So you can see we can lock the 2 and the 5 into those squares there, because of the 2 and the 5 over on this side. So these two squares must be 3 and 8. And that resolves to 3 and the 4 over on this side. That must be that way round. That gives us a 4 here, just unwinding the pencil marks that we had earlier. This square now can only be a 7 because of the 3-8 pair there. Now there's a 7 in one of those two squares, look, because of these 7s here. What do we need? 1, 5, 8, and 9. So there's an 8 in one of those two squares, and a 1 at the top there. So we've now pencil marked everything in this box that we could possibly do. Still left with 2, 7, and 8 over here, which we Well, the 7, I suppose, means it's a 7 in one of those two squares. Let's put that in. Right, so, goodness me, this is proving a lot more involved than I was expecting. So 1, 2, 6 and 9 down here now. Oh no, 1, 2, 6 and 8 I should say. So the 8 here means there's an 8 in one of those two squares. This is a 2 or a 6. Maybe I should. What's the options for this square here? So this square can be 2, 3, 8 or 9. But there's 8's pencil mark there and a 2 here. So this can only be a 3 or a 9. This one can only be 2. Oh, this can be a lot of things, I think. 3, 6, it can't be 7. 3, oh no, only 3 digits. 3, 6 or 9. I'm just looking down this column now to see whether I can see any other big restrictions. Obviously, I've pencil marked it because I've fully pencil marked this block. These effectively are all pairs. In fact, I could label them as such if that helps you guys to see it. Look, we can write those in. That's why I was looking at this column. Now that square is restricted. All I'm doing here is comparing rows and columns and just trying to see where I've got a lot of differential between the digits. So you can see this square can be a 3, but it can't be a 4, 5, 6, 7. So it can be a 9. There you go. 3, 9 here. Goodness. Maybe that was there. No, I don't think it was there from the start because I needed the trick over here to get the 4 and the 5. So I think that is new logic. That's not something I missed earlier. So 6 here. Now, what does that mean? That means this is a 6, and this is a 6, just normal Sudoku using the 6 up here. The 3, 9 here means we need 1, 2 and 8 to complete this block. So we're still not quite sure where the 2 is going. 2, 5, 3. Let's get rid of that. Must be a 7 now from the earlier pencil marks. I'd highlighted it was a 6 or a 7 through the central notation. So that's going to be an 8 here. Must be an 8 now in one of these two squares. Now that marries up. So again, that's just the way I solve. You can see the moment I pencil mark these 8's in here, my eyes were looking upwards and downwards to check whether I could find 8's in the same columns in either of the other boxes. And look, so we have this pattern of 8's here. So we know that if in the finished solution this is an 8, then this will be an 8. And on the other hand, the only other state of affairs that could exist is that this is an 8, in which case this will be an 8. So when I come down to this block down here, there's no way 8's can go in those squares, because there will either be an 8 here or an 8 here, and similarly on this side. So that actually allows me to pencil mark 8's into those two positions, along with the 9. So now we've got an 8-9 pair in this block. And therefore we know these two squares now must be 2, 3 and 5. So with 5 over here, this square is a 2 or a 3. And that's 2, 3 or 5. Right, so let's come back over here. We need a 2 into one of those two squares, and you can see that's going to be useful. Because now there's a 2, 3 pair, look, in those two positions. And that means this square here, that's going to have to be a 6 because it can no longer be a 2. 6 here. Now where can a 6 go in this 3x3 block? You can see it can only go here, and the moment I place it here, a few things happen. Firstly, I can place the 5 because of the pencil marks, and now the 5 and the 2 must unwind at the top, and this 6 means the 6 and the 4 unwind as well. This 4 means these 4s also get unwound. So a flurry of activity. This 5 now points at this square and forces the 5 downwards, so we're able to go 5, 9, 8, 1. This 9 here sees this 3-9 pair at the bottom. We can now unwind that. Finally, we resolve this square over here. That's going to be a 2, therefore this is a 3, because we know these form this sort of weird pair around the corner. This square now must be an 8. We need an 8 and a 9 to complete the final row of the grid, and there's a 9 here. So 8, 9 like that. 7 and an 8 into these two squares, so let's pencil mark those. 7 and an 8 into these two squares. Therefore this should be a 2 at the top. Complete that row, and that looks like it's working. This is not an 8 anymore. These two squares need to be 1 and 2, and there's a 1 here, so it's 1, 2, 1, 7 and 2, 2 and 3. These two squares are 2 and 3, aren't they? So the 2 there sees that one. Oops. So we can go 3, 2 like that. Just trying to make sure I'm not making any errors here. Obviously we've now got 7 and an 8 into these two squares. This is also 7 or an 8. If we look down the column, we need 3, 7 and 8 to complete it. And there's a 3 over there. You can see also we've already got an 8 in there as well. So that's a 7, that's an 8, that's a 3, that's an 8, that's a 7. This 7 here feeds back over into this side, 8, 7, 7, 8 like that. That resolves this 8 and 9 as well. And finally 3, 5 into these squares. And that is correct, and it's a hell of a puzzle. That is a really, really interesting puzzle. Now, I probably missed something at the start, but even if I did, I don't really mind, because that was really cool. This 2-3 effect down here and down here was worth doing. So I hope you guys enjoyed watching that. Be interested to hear in the comments what I missed, and yeah, we'll be back soon with another edition of Cracking the Cryptic.